Okay, in problem number 1, we need to determine the angle of elevation. So the angle of elevation to the top of the hill is going to be this angle right here. So we know that the opposite of this angle is 75, and we know that the adjacent is 45 feet. So opposite and adjacent make tangent. So the tangent of this angle, we'll call it theta, is 75 feet over 45 feet. Well, we don't want the tangent, we want the actual angle, so we're going to use inverse tangent. So the inverse tangent of 75 over 45 is going to give me this angle, and this angle, when I punch this in my calculator, is approximately 59.03, which rounds to 59 degrees. Okay, in the figure, what is AD in centimeters? So we want to find AD. Okay, so we know that we have a right triangle here. So a right triangle, we have two sides, so we can use the Pythagorean theorem. So a squared plus b squared equals c squared. The hypotenuse in this case is 68 centimeters. One of the legs is 32 centimeters. We need to find the other leg. So in that case, we have 68 squared, which is 4624, and 32 squared, which is 1024. I'm just going to algebraically solve this by subtracting 1024 from both sides. A squared is going to be 4624 minus 1024, which is 3600. So we square root both sides, which gives us 60. So this side is 60. Okay, now that we know that that's 60, we're going to find this side right here, which is what we've been looking for. So we're going to do the Pythagorean theorem over again. So a squared plus b squared equals c squared. In this case, our c is 60. One of our sides is 36 centimeters, and we're trying to find the other side. Okay, so 36 squared is 1296. We know that 60 squared is 3600. We're trying to find a. So a squared is equal to 3600 minus 1296. We want the square root of that. So it's 2304. We're going to square root both sides, and a is equal to 48 centimeters. So this side is 48 centimeters. All right, problem number 3. We want to find the measure of angle B. Okay, we actually had this on an earlier homework problem this week, so hopefully you remember how to do this. These form a straight line. So this is 180 minus 130, which is 50 degrees. Okay, this is a triangle, so we've got 90 plus 50 is 140 degrees. So 180 minus 140 is 40 degrees left over, so this is 40. Okay, this forms a straight line. This also forms a straight line, so if this is 90, that has to be 90 as well. So 51 plus 90 is 141. 180 minus 141 is 39 degrees, so this has to be 39 degrees. And then since these form a straight line, we know that 40 plus b plus 39 has to equal 180. And we know that 40 and 39 is 79. So if we subtract 79 from both sides, we get b is equal to 101 degrees. 101 degrees. Okay, problem number 4. Asks us to find the tangent of angle B. So we know that angle B is right here. All we need to do is find the tangent. So tangent of B, tangent is opposite over adjacent. So the tangent of angle B is going to be the square root of 95 over the adjacent, which is 7, and that's all we have to do. Okay, problem number 5 asks us to use the law of cosines to find the measure indicated. So the law of cosines, you should remember the law of cosines is c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. We usually put this in brackets so that we remember it all goes together. So we're trying to find AB, which is this side over here, which works out because that is little c. So we're trying to find little c. We know that little a is 12. We know that little b is 21. Okay, so 12 times 21 times the cosine of angle C. Angle C is 89 degrees here. So we can plug that in. So this is 144. This is 441. 2 times 12 times 21 is 504 times the cosine of 89 degrees. Okay, 144 plus 441 is 585, sorry. The cosine of 89 degrees equal to c squared. I'm going to square root. I'm not going to square root both sides. No, I am. I can square root both sides. I actually could have square rooted both sides at the beginning up here because I knew everything except for the c. So I could have just went ahead and punched that in my calculator and square rooted it there. It doesn't hurt. So I'm going to square root this. Okay, and when I put into my calculator, I get c is approximately 24.0 miles. All right, we're asked to use the law of sines to find the measurement indicated. So the law of sines is the sine of A over little a is equal to the sine of B over little b is equal to the sine of C over little c. Okay, in this case, we have D, E, and F. We're trying to find DF. Okay, so we want to find DF. So we'll make that X. The sine of the angle opposite that would be the sine of 113. Okay. I know this side right here, which is 8 meters, and I need to do the sine of the angle opposite that. Well, I can find that pretty easily because I just know that angle F plus 25 plus 113 has to equal 180. So if I add 25 plus 113, I get 138. So if I subtract 138 from both sides, F is equal to 42 degrees. Okay, so now I'm going to cross multiply. So the sine of 42 degrees times X is equal to the sine of 113 times 8. We divide both sides by the sine of 42 degrees. And I get X is approximately 10.6 meters. Okay, we're asked to figure out which of the statements are true. So we know that this is a line of symmetry for the figure. If this is a line of symmetry, then the figure has to match up on itself when we fold it over. So this one, the measure of angle E has to be 70. It does because they would have to match up. So we know that one's true. All right, point F is the midpoint of AE. Well, A has to match up with E, so yes, that has to be true. And then this asks whether it has more than one line of symmetry. And it does not appear to have more than one line of symmetry. There's no other way to fold this, so it's just 1 and 2. All right, problem number 8. Given the diagram below, which statement is true? Okay, AC is the longest segment in this figure. So let's see, AC. AC is opposite a 60-degree angle, but we have an 80-degree angle, and we know that sides across from larger angles are longer. So AC is not the longest segment. AD is the longest segment in the figure. Well, let's see. So AC was across from the 80 in this one, but it was only across from the 60 in this one. So we know that AD has to be bigger. So is there anything else that could be bigger? No, because this is a smaller triangle, and in this case, there's no bigger angle in this one, so that would be true. All right, AC is equal to AD. No, the angles across from there are not congruent, so they're not equal. And this says that AC is larger than AD. No, AC is smaller because it's opposite a smaller angle. So correct answer here is B. If triangle ABC is congruent to triangle DEF, AB is equal to 2 feet. Okay, so let's draw this. So we have ABC, and we have DEF. AB is 2 feet. The measure of angle B is 15 degrees. And the measure of angle F is 51 degrees. Which of the following statements is false? Well, we know that they're congruent. So let's go in the correct order. So if AB is 2, then DE has to be 2. If the measure of angle B is 15, the measure of angle E has to be 15. And if F is 51 degrees, then C has to be 51 degrees. All right, so this says, which statement is false? Well, ED is in fact 2, so that's not false. All right, the measure of angle D is congruent to the measure of angle A. Well, that's actually true. They match up, so that's not false. All right, the measure of angle A is 114 degrees. Well, let's see. 51 plus 15 gives me 66 degrees, and then 180 minus 66 does in fact give me 114 degrees. So this would be 114 degrees, as would this. So that's not false. All right, this says ED is equal to AB. Well, they are in fact equal to one another. So let's go back. Maybe we misread this. So let's see. Measure of angle A is 114. No, that's true. These are true. All right, the measure of angle D is equal to measure of angle A. No, that's true. Now let's go back here. FD is equal to 2 feet. I thought that said ED. It did not. It said FD. FD is not 2 feet. So that is the one that is false. That's why it's very important to make sure you rule out all of them. So in case you made a mistake, you can go back and fix it. All right, number 10. We've done this one already. The diagonal is 12. If the diagonal is 12, it's a square. So that means this is a 45, 45, 90, because we had to split a square in half. So 45, 45, 90. And across from the 90, we have 12. Well, let's put our pattern first. So we know that it's x, x, x radical 2. Now we have a 12 here. So to go backwards, we have to divide by radical 2. So 12 divided by radical 2, we got to rationalize that. So it's 12 radical 2 over 2, which is 6 radical 2. So each of these is 6 radical 2. And we know that area is length times width for a square. So the area is going to be 6 radical 2 times 6 radical 2. Well, 6 times 6 is 36. Radical 2 times radical 2 is 2. So the area is 72 inches squared, or square inches, same thing. Okay, problem number 11. Eliza likes to make daily events into games of chance. For instance, before she went to buy ice cream at the local ice cream parlor, she created 2 spinners. The first has her favorite flavors, while the second has cone and dish. Eliza will order whatever comes up on the spinners. What is the probability that she'll be eating Tutti Frutti ice cream from a dish? So Tutti Frutti, the probability is 1/3. So the probability of Tutti Frutti and dish, it's going to be 1/3, which is Tutti Frutti, times 1/2, which is the dish, so that's 1/6. That is her probability. Okay, problem number 12. Betty is going to flip a coin 3 times. What is the probability, Barty, what is the probability that he will see at least 2 tails? Construct a tree diagram. So, the first flip is either heads or tails. It's a 50-50. He has another flip, and he has another flip. They're all heads or tails. Alright, so this is a half, 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 a half, 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 half. Lots of halves here, lots of halves. Alright, so our probability of heads, heads, heads. What is that probability? It's going to be 1/2 times 1/2 times 1/2, which is 1/8. Okay, this one's also 1/8. They're all 1/8. So there's 8 of them, they're all 1/8. We want to know at least 2 tails. So 2 tails. So I'm going to pick a different color here, and I'm going to see which ones are 2 tails. So this one is not 2 tails. Alright? This tree would be heads, tails. It would have to go, so this one would be 2 tails, because it would be heads and then tails, tails. This one would be tails, heads, heads, so that would not be it. This one would be tails, 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 that would work. Tails, tails, heads, that would work. I'm going to go back and fix this. The reds we don't want. The blacks we do want. Okay? So, let's see. What else would work? Tails, heads, tails would work. And heads, tails, tails would work. So those are our options. So this one would be 1/8. This one would be 1/8. This one would be 1/8. And this one would be 1/8. So it's 1, 2, 3, 4/8, which would be 1/2. So the probability is 1/2. Okay, number 13. Each morning, Aaron starts his day with either orange juice or apple juice, followed by cereal, toast, or scrambled eggs. How many different morning meals are possible for Aaron? List all the possible breakfast combinations. So, he can have orange juice with cereal. He can have orange juice with toast. He can have orange juice with scrambled eggs. He can have apple juice with cereal. He can have apple juice with toast, and you can have apple juice with scrambled eggs. So he has 6 options for breakfast. All right, in the U.S., approximately 10% are predominantly left-handed, while 90% are predominantly right-handed. About 40% of individuals are blue-eyed. Almost about 55% have some form of brown eyes, and the remaining 5% have other color eyes. Make an area model illustrating the possible combinations. Okay. So I'm going to try to make an area model that is clear here. So 1/10. So this is about 1/10. of the square. So handedness, left and right. So this is about 1/10. This is about 90%, 9/10. I mean, we can say 90%, or we can say 9/10, same thing. Okay, and then eyes, we have 40%, so this would be about 40%. We have 55%, only about 5, so this is going to be really small. So this is 40% are blue-eyed, this is brown-eyed, and this is other. And we want to know the probability of someone being left-handed and brown-eyed. So left-handed and brown-eyed, we want this one right here. So what is that probability? Well, blue eyes was 40%, brown eyes was 55%, other was 5%. So this is going to be 10% times 55%, which is 5.5%. 5.5% of the population is left-handed and brown-eyed, approximately. Okay, and last but not least, problem number 15. We have a bag containing the figures. If you reach in and pull out a shape at random, what is the probability that you pull out a figure that has at least one right angle? So let's take a look. Okay, of these shapes, how many have at least one right angle? One, two. So 2/5. Which is also 40%. Okay, a figure with an acute angle. So an acute angle, let's see. Acute angle means less than 90 degrees. This one does have an acute angle. All right, this one has an acute angle. This one does not have any acute angles. This one does not have any acute angles, and this one does. So 1, 2, 3. The probability of acute angle is equal to 3 out of 5. A shape with at least one pair of parallel sides. So I've got 1, 2. So the probability of greater than or equal to 1 pair parallel is going to be 2 out of 5 again. And a triangle, the probability of a triangle is also 2 out of 5. Hopefully this video was helpful.